Welcome back. This is Mr. Greenstein's Geometry, and we're in Chapter 12.2, Independent and Dependent Events. So in independent events, there are two or more events whose outcome where one event does not affect the other. Dependent events is where two or more events where the outcomes do affect each other. So let's take a look at rolling two dice. Are they independent or dependent? Well, if I roll two dice, they're going to be rolling independent of each other, especially if they're not going to be next to each other. And when they land up, they're going to land independent of each other. So these are independent. On the other hand, let's say we have 6 slips of paper in a bag, and we randomly pull out one, and now one is not in the bag anymore. If I was to go and choose another slip, obviously I have less slips to choose from, and I don't have one in there. So the second choice is going to be dependent on the first choice. Therefore, it is dependent. The probability of independent events, let's just concentrate on that. That's where the probability is the product of the probabilities of the events. So we have the probability of A and B, these are independent, remember this is just independent, is equal to the probability of A times the probability of B. So let's take the two six-sided dice. What are the probability of rolling 2 6s? Well, the probability of rolling a 6 is going to be 1 out of 6. So the probability of rolling 2 6s is going to be probability of dice 1, which is 1 6, times the probability of dice 2, which is 1 6, and that's going to equal 1 out of 36. So 1 out of 36 chance of rolling 2 6s. Let's look at this problem. We have a group of 5 students, and I'm going to randomly choose one to be a speaker and a different student to be a recorder. Speaker and recorder, and I have 3 boys and 2 girls. So now I'm going to build a table, and in this table I'm going to say, well, let's say I choose boy 1 and then boy 2, or boy 1 and then boy 3, boy 1, girl 1, boy 1, girl 2. Then I look at the next possibility, speaker being boy 2, and recorder B1, boy 1. And then just keep enumerating each one of these, all the different possible outcomes. If I randomly selected a speaker, which is the first one, and a recorder, which is the second one. So I want to find out whether selecting a boy first and randomly selecting a different boy second are independent. Well, if I look at these, I've got the probability of picking the first boy, one boy, is 1 out of, it's going to be 12 out of 20. Because if I look, all the places where boys are selected first, 1, 2, 3, that's 12 of them. So 12 out of 20 is going to be my possibility of picking it for a boy as a speaker. Probability of picking a boy second, well, that also I look at all the places where a boy comes in second. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10. Then here's some more, 11, 12. So 12 places where a boy is chosen second. So I write that. That's going to be 12 out of 20. And each one of these is 3/5. So if I take 3/5 times 3/5, I get 9/25. So the possibility of picking a boy and then another boy in this scenario is 9 out of 25. But what if I use the probability of picking a boy, first a boy, and then second another boy, and look at that? Well, if I look at the places where boy and then boy, I have 6. There's 6 of them here. So it's 6 out of 20. It turns out that 9/25 is going to be 36%. And this is 30%. So this tells me that since these two probabilities are different, then these are dependent events. And we will talk about more of this in the next video.